Hi, ladies and gentlemen. Today we have a very exciting webinar, MAPEI's Waterproofing Systems and Solutions. And our presenter today is John Humbrecht. John is currently the concrete restoration and waterproofing specialist for MAPEI Corporation in Louisiana and Mississippi, where he works with architects, engineers, consultants, contractors, and distributors to bring complete MAPEI product solutions to the job site. He has been with MAPEI for 6 years and brings more than 25 years of construction industry experience in commercial and industrial product sales and application. John is a member of the ICRI Gulf South chapter and active in local AIA events and presentations. Just as a housekeeping item, if you have any questions, drop them in the question box. We'll do a Q&A session at the end where John will answer all of your questions. And also, if you're interested in joining My MAPEI, we encourage you to do so. It's a really great account to have. You get our monthly e-blast. You get access to some of our latest product information and webinar information immediately. And you can save calculations with our MAPEI resources and tools. So it's a really great thing to have, a great resource. And without further ado, John, the floor is yours.
Hey, thank you very much, Brian. I appreciate it. And thank everybody for being part of this webinar today. But we were having a little bit of technical difficulties, and that's why we're starting late. We still have them. So you're probably seeing my PowerPoint, not kind of the refined presentation screen, but just the regular PowerPoint program. So just bear with me there. I also have lost some of my notes in there, but that's okay. We're gonna do something good with this. So today we're going to talk about MAPEI Waterproofing Systems and Solutions. Hopefully everybody will come away knowing something more than they did before about applications, different situations you might find with the need for waterproofing on projects. So let's go ahead and get it kicked off here. We're going to start talking about waterproofing versus damp proofing. So it's pretty simple, actually. Waterproofing is defined by ASTM as the resistance of water under hydrostatic pressure, whereas damp proofing is the resistance of water that is not under any type of pressure. So, a good example I like to use for this, just to kind of make it kind of simplify it, is a cell phone. If you think about your cell phone, you get caught in a rainstorm, phone gets wet, you just dry off the phone and away you go. You usually don't have any issues. But you're at the swimming pool, you drop your phone in the deep end of the swimming pool, it sits there for a few minutes, and water's probably getting in your cell phone at that point. And the difference is, obviously, is that when you got caught in the rainstorm, that water was not under pressure. So compare that to damp proofing. So your cell phone cover, basically as it comes, is damp proofing. The pool situation would show that your cell phone was not waterproof, and because the water, forced its way into your phone. And so that's just a way to look at it as far as the difference between those types of products. Obviously, waterproofing is a much more water resistant, durable product. Another thing to keep in mind is that damp proofing products usually will not bridge cracks in concrete like waterproofing materials will. So damp proofing materials, they can have some flex to them, but they tend to be a little more brittle, whereas waterproofing products across the board are usually pretty elastic. So they can usually accommodate cracking, minor cracking, movements in the slab, things like this. And even really, if you think about like on a masonry or a brick wall, something like this, where there might be shifts in the masonry or some cracking, waterproofing is a good choice. So just kind of taking that another step further, talking about the hydrostatic pressure with the when we're talking about waterproofing versus damp proofing. So hydrostatic pressure is basically, if you look at this drawing here, picture that as maybe 10 feet below grade on a building, with that H on the right side being the height. And then you can see as you go down deeper, or as the water table rises, you tend to get a higher water pressure at the bottom. And this is why when you go to the bottom of a deep swimming pool, you know, your ears pop, you can feel the pressure because there's a higher column of water on top of you. So that's something important to understand. What are some of the characteristics of an ideal waterproofing system? So let's just talk about what do we want a waterproofing system to do. It does need to be effective against moisture intrusion. Obviously, it's a waterproofing system. So everything about it needs to prevent water or moisture from getting into the building. Another thing is it's very important that it's continuous. I always say, you know, if water's going to find a way to get in. So if you have a system where, you know, 95% of it is beautiful and it's solid, and then you've got a small area, maybe it's a pipe penetration or a crack in the concrete, anything like that, water is going to find a way to get in. So it's very important that it be a complete system where all those types of details and joints are taken care of. Really should, I mentioned the accessories. A real good system is going to have accessories with it. We'll talk about all this stuff, but it's going to have joint sealants to go along with the main structural waterproofing. It's going to have drainage boards, different things like that. It's better if it's easy to apply, so anything that's easier to apply is probably going to be done better or more consistently. If something is difficult to apply, that really just means that it opens a door for errors. It opens a door for maybe details to not be done exactly correctly, and that could allow water to come in. Durable during and after construction. Very important, because you say, well, why during construction? Well, the waterproofing contractor gets in there. Let's use that below grade wall we were just talking about. The waterproofing contractor gets in there. He waterproofs that wall. It's nice. It's solid. He's done. Now he's still got a pit down there that was dug out. Well, after him, you may have mechanical, plumbing contractors, electrical contractors, anybody like that could be coming in behind him to maybe hook up to penetrations in the wall, stuff like that. And so you don't want a system, once it's fully applied, to be something that, doesn't have some type of durability to withstand somebody bumping up against it or leaning against it, this type of stuff. And obviously it needs to be durable after construction, because if we're talking about, I'll use the example of below grade waterproofing. Think about like an elevator pit underneath the building. Maybe it's in the center of the structure. Once that building slab is poured, that elevator pit, for all intents and purposes, is buried for the life of that building. So you'll probably never again get access to the outside of the walls of that elevator pit. So it needs to be a system that will last, be expected to last the life of the building. And then, very important, that's installed by a reputable applicator, a reputable contractor. You want somebody that's done this before, that knows what they're doing. Even if they haven't installed the same brand, maybe they've installed somebody else's brand, but it's the same types of systems. That's what you want, somebody that knows what they're doing. So how does water enter a foundation? Well, there's lots of ways that water can get in. We talked about the water table rising. We talked a little bit about hydrostatic pressure. Site drainage, that can be a big issue. That's kind of what this picture here is showing. I've probably seen more projects where it was an issue with water not draining properly from the site. So before we even talk about how well you waterproof a structure, we first need to talk about, are we even moving the water away from the structure? That's the first step in waterproofing. Let's get the water away from the building, and then we can talk about how we're going to protect the building itself from the water that stays there. Other things, snow melt, water main breaks, things like this happen. Cracks and joints, though, and then improper waterproofing details. This can be a big deal. So cracks and joints in a concrete wall, in a masonry wall. I mentioned penetrations, all that can allow water to get in. And then improper waterproofing details. We did the waterproofing, but somebody did not, I don't know, somebody didn't use the right joint, didn't use a joint sealant in the cove, or somebody didn't overlap the waterproofing systems correctly, and they allowed a gap for moisture to get in. So that's something to keep in mind. Now we'll jump a little bit. Let's change gears. We kind of talked there a little bit about waterproofing in general. So let's talk about the types of waterproofing that MAPEI can offer. And I'll say this is for, four primary categories of products that we offer. But it's by far not the only waterproofing systems or products, because there's several other products, several extensions on these product lines. And then there's a lot of accessories that you would consider waterproofing, but they also can be accessories with these waterproofing types. So just keep that in mind. We're going to address four of them here, though, that you probably would run across situations, I would say quite often, where some of this can be used in really every project in some form or fashion. Probably has some type of waterproofing going on. So let's see here. Okay, there we go. Let's first talk about cold fluid applied waterproofing. And by cold fluid applied, we say, well, why do you say cold fluid applied? Why not fluid applied? Well, I'm kind of differentiating it from hot fluid applied, which would typically be, say, like a hot asphaltic product. Side note, if you've ever been around one of those applications, it's you don't want to be too close to it. So those hot asphalt waterproofing, liquid waterproofing systems are, they're usually involve some type of kettle heated to a very high degree with flames. A lot of times the people applying the material are wearing like protective suits and gloves, and it puts off a very strong asphalt odor, really kind of over the whole area you're working. So this is something where I'm telling you, you can achieve the same thing. You can achieve the same results, but with a cold applied system, typically right out the pail, that doesn't have any odor and it's safe. You don't have to wear special equipment. There's no, you don't have to have the fire department on standby. So, what are some of the advantages of the cold fluid applied system? It's very easy to apply, first of all. There's a much better chance to get it right. So I had mentioned that a little bit. If it's easy, there's more chance that you're going to get it right. It is a seamless and fully adhered system. So look at that picture on the right, just kind of gives you an idea. There are no seams, there's no gaps. As long as you do it correctly, everywhere that you're going to waterproof, vertical, horizontal, back down onto the footing, it's all flows as one continuous waterproof system. And because it's fully adhered everywhere, you don't have a chance of water, say, migrating along the wall, behind the waterproofing system, which can be a problem if, say, you had a leak in one area and the water migrated 10 feet to the left and then went inside the building there. You might have a real difficult time figuring out where the water is coming from. The detailing on this, as far as around pipes, that type of stuff, very easy. Hey, adhering to irregular and rough substrates is a big thing for liquid applied waterproofing, because my experience anyway has been that a lot of times on real job sites, the surface, you'd like to have it smooth. You'd like to have it nice and smooth, everything patched, sharp edges ground down. But in reality, a lot of times you've got rough areas. I mean, you can look at this picture here on the right, and I mean, they did a pretty good job. I mean, but you have some rough areas of concrete there. Liquid waterproofing will go over all that. As long as it's not too crazy, you'll still get your coverage. And then we do have reinforced options, and we're going to show you that as well, to where you can have a single layer system, or you could have a reinforced double layer system in varying thicknesses. We'll get into that, but there's a lot of options. what are some of the common types of cold fluid applied? So now we're breaking it down. So we're talking about cold fluid applied waterproofing, and now we're breaking it down to the types of cold fluid applied waterproofing. First one we'll talk about briefly is polyurethanes. Polyurethane is very common. You've heard of polyurethane, joint sealants. There's a lot of polyurethane products. They have very good elongation properties. So they have a lot of flex, which is good. The only problem that you have when we start talking about waterproofing products and even especially below grade waterproofing products is that polyurethanes have a risk of reemulsification if they're exposed to water for a long time. So what does that mean? That means that if a polyurethane product sits underwater, say the water table comes up and it just stays there for a week, 2 weeks, polyurethane, there's always a chance that it can start to soften up and revert back to almost like when it was first applied, right out the tube or right out the pail. So that's an issue. Polyethers, on the other hand, polyethers, they're actually in the polyurethane family, same, a lot of the same chemical makeup, but they are good for long-term water immersion. So polyethers can stay underwater indefinitely. So that's why we're not worried about, hey, use, and you can see I put there the MAPEI system, which we'll get into, is a polyether. Water table can come up. If you remember down here in Louisiana, which that's, by the way, I didn't mention that, but I'm actually down in the New Orleans, Louisiana area. But several years ago, we had the rivers come up, Mississippi River, a lot of the waterways came up, stayed up for a long time. We had a lot of below grade water issues. A polyether can hold up to that. It can just stay wet forever. I mean, you can use it inside of a planter, say a rooftop planter where you're continuously watering. It's not going to re-emulsify. The only thing with polyethers is that they're not really compatible with asphalt-based products. So if you're trying to overlap maybe an asphalt product that was existing or something, it can't go directly on top of that, but it's a very simple fix. We actually have a transition that we can do. It's a detail that makes it a piece of cake. So that's almost not even a negative anymore. Acrylics they tend to be less expensive. They are very tough, but they don't have a lot of flexibility to them. Think of, you go to Home Depot, for instance, and you get a low end joint sealant to seal around your windows, your home windows or something. There's a good chance it might be an acrylic. And you notice over time, they're real easy to work, but after a long time, they tend to harden up and crack. Asphalt emulsions. Now, I'm not talking about the hot applied material here. I'm talking about like right out the pail, the black asphalt type materials. Traditionally, they were kind of lower cost than other products. Although what I'm seeing lately, that's not necessarily the case. They're getting in line with other polyethers and polyurethanes, but they also don't adhere real well to each other. So sometimes if you have to go back over an old system or you have multiple layers, they don't have the best adhering to each other, whereas polyethers and polyurethanes do stick very well to each other. And then there's hybrid systems. We don't see a whole lot of those, but it's kind of an attempt to mix some of these to maybe reduce cost and this type of stuff. So let's get into talking about, I had mentioned the thickness of the material and different options. Let's talk about the thickness in the application. So typically, right now, what we're talking about is dry film thickness. So we're talking about after the material is cured, how thick is it? You have options for a 60 mil system. You could have a 90 mil single layer system, or you could have a 90 mil reinforced system, which would be like a 45 mil layer reinforcing fabric and another 45 mil layer. And then you could have up to 120 mil system. But something to think about when you say, well, what do I choose? What system works for my project? Typically, the thickness impacts the warranty. So what do I mean by that? If you say that, for instance, you want to get a 5-year material warranty, that's all you want, that's all the project requires. And by the way, that's pretty typical. A 60 mil single layer system is probably sufficient because you could get a 5-year warranty. At least with MAPEI, you could get a 5-year warranty with that. But you have a deal where you say, hey, we need a 20-year warranty, or maybe we need a 20-year labor and material warranty. Well, in that case, what would be recommended would be, say, a 120 mil reinforced system. So 60 mils fabric, 60 more mils of CR1, and you could get a 20-year warranty on that. So that's important to keep in mind. Now, I'm going to talk a little bit more here about wet film and dry film thickness. And this is something, okay, there's a lot of math and numbers on this screen, but just pay attention, just think about this, because this is really important when you're talking about the product you use, the coverage rates. So the only time that the wet film thickness is the same as the dry film thickness is when it's 100% solids membrane. And what do I mean by that? When you have a product like this pail that I have down here on the left, that's 80% solids. What that means is it's got 80% solids of the product and it's got 20% of a solvent in there. And the solvent is just a carrier. It helps with the curing process. So what happens? You could apply 60 mils of that 80% product onto the wall, and it is going to shrink by the percentage of solvents that are in the product. So that 60 mils is going to shrink down by 20%. You're not going to be left with 60 mils. You're going to be left with something less than that. So that's something to keep in mind. If you can buy a 100% solid system for the project, why wouldn't you do it? Here's an example of where that comes into play. So let's say the architect is specified, they want a 60 mil system installed on this below grade wall. That's what they want to end up with, 60 mils. You use an 80% solids product. To get the amount of material you need to put on wet for it to end up 60 mils, you would take 60 mils divided by 0.80 or 80%, and that gives you 75 wet film thickness. So what does that mean? That means I have got to put on 75 mils of that 80% product if I want to end up with 60 mils. I got to put on 75 mils. It's going to cure and shrink, and I'm going to end up with 60 mils. Well, what does that mean? That means I literally have to buy 25% more material of a lower solids product to get the same coverage rate at the same thickness as 100% solids. I don't know. Let's say you're doing 1,000 square feet, and you've got to cover that with waterproofing. You use the 80% solids waterproofing. You're going to have to buy 1,250 square feet worth of material to end up with 1,000 square feet. I may be overanalyzing this, but in my mind, I'm just thinking that in effect means that you're spending an extra $250 or 250 whatever to throw that material away, to watch it evaporate in solvent. So that's kind of how I look at it. So I would always go with 100% solids as the bottom line. So going along that line, let me talk about the MAPEI Planiseal CR1. So this is our cold fluid applied waterproofing. There's some really good benefits, features of this. Oh, let me get back to it. First of all, it is a single formulation for horizontal and vertical applications. That means that this is one product. It's one pail. It can be applied horizontally, vertically. You're not having to either specify or purchase, let me specify a vertical waterproof and then let me specify a horizontal waterproof. One product for both applications. No priming required. This is something that is literally right out of the pail and onto the clean substrate. It is a single component, no mixing, so that makes it easy. So we had talked about the easier it is to apply, the more likely it is to get it right. So this is just about as easy as you can make it to apply this system. Very low odor, almost no odor. I can tell you could apply this product indoors and you wouldn't have a problem with it. If you've ever been around a high solvent or like an 80% product, it puts off very strong solvent odors. The VOCs are very high, and if you think about it, these contractors are usually working, if they're working below grade, they're kind of in a trench, and solvents tend to sink. It's heavy. So, and they're right up against it. So when they're applying waterproofing, they're right there applying it. So it's really nice to have something that really has no odor. They can work right in front of it, no health issues. This is uh, a neat deal with it. It's suitable for green concrete after 3 days. So you could pour a wall, and within 3 days, you could apply this material to it. And it's rain resistant as little as 2 hours. So I don't know what part of the country you may be tuning in from, but I know down here in Louisiana and probably a lot of other areas, Northwest, Florida, you'll get these pop-up showers. You didn't expect them. Well, if you had a system that was not resistant in some way to rain after a short period of time, it would wash that material down the wall and you'd probably have to start over. So 2 hours, you're good to go. You don't have to worry about the rain washing it off. No special application equipment. It can be applied by squeegee, brush, roller, trowel. And as I mentioned, it is a 100% solids product. So that means you put 60 mils of CR1 on the wall wet. You use your little mil gauge, measure it. You know it's going to dry 60 mils, so no problem there. And then look at all the areas that this can be applied in the substrates. It can be applied to concrete, wood, metal, insulation, stone, and just all types of applications. I've been talking about below grade, but plaza decks, balconies, planters, split slabs like on a parking garage, tunnels, a lot of applications. And something else that's good about, it's kind of ironic I'm talking about this today, but Planiseal CR1 has been approved by Miami-Dade County for their stringent building code regarding the high velocity hurricane zone of their building code. So our full system has been approved, and I think we're all familiar that the Florida building code is one of the most stringent in the country. A lot of manufacturers build their products to that standard. It's just it's unfortunate and ironic that we have a very large hurricane headed toward the Florida coast. So we think about all those folks over there, but it is approved for that type of weather. Here's kind of an illustration for you of how the reinforced membrane works. So just following the numbers, that number one there, they're rolling out the first coat of CR1, and then at the top there, number two, they're just taking that fabric and they're laying it out. That fabric, if you could see it, it almost looks like that. I tell you, it reminds me of the fabric on the underside of like a box spring mattress. That's kind of what it looks like, but it's a lot stronger. So they lay that out, and then you see step three, they're actually taking that is a dry roller. That's not more material in the roll. It's a dry roller, and they're just lightly rolling that roller over the fabric so it absorbs the CR1 on the first layer. And then I usually recommend you let that set up for a short time, an hour, 2 hours. And then in step four there, he's coming back with the second layer. So what he's just done there is kind of completed the waterproofing sandwich, the reinforced waterproofing with the fabric in the middle. Very simple. I mean, you gotta, you want an experienced contractor to install it. You want to make sure they do it right. But on the scale of difficulty of difficult systems to apply, this is on the easier end of it. I'll say that. Let me show you a few projects, really nice projects. This was a really nice one up in Pennsylvania that we had. Great job up there. It's 35,000 square feet. What you are looking at, it looks like they're rolling this on the ground. That is actually the roof of several below grade parking deck structures. So there's parking garages down there, and they had an old system on it before that had failed. So they had to get all the way back down to that concrete, clean it off, and now they're applying the CR1 system over the whole area. It was a reinforced system with the LMR fabric and then the MAPEI drain. And look, here's the finished product. So after that's all done, they come back, and I mean everything they would need for normal landscaping. There's your asphalt road, your sidewalks, all that is on top of that system. and this is a little while back, and the system is held up beautifully. So you would never know there was a parking garage under there. This is a good example that you probably see all around the country. This was over here in Louisiana. This was the pit for one of those oil change facilities. And whether you know it or not, every time you go to get your oil change at a quick lube or whatever, there is a big pit underneath that they obviously get to your car from down there. That's where they work. So that has to go in first before the building, obviously. And this was actually a pretty big one. It's hard to tell from the picture. Nice sized oil pit. And they used the Planiseal CR1. They just used a single 60 mil layer. Got a 5-year warranty on it. But look how well that's done. You can see in the top left, that is where they did kind of the detail coat all around the edges, which we recommend. And then they sealed all the joints around the bottom with a nice chamfer of joint sealant before they put that detail coat on. And then they went around and coated the whole thing, seamless all the way through, all those bends in the concrete. It's all seamless. And then you can see in the top right, the contractor was very good about checking his thickness as he went along to make sure he was consistently at 60 mils. So he did a really great job on that project. And then they came back and put the MAPEI drainage board, the protection board. You can see on the left there, they kind of layer it like shingles. So they put the bottom row down, and then the top row overlaps the bottom by a little bit. So, and then of course all that gets backfilled. And here's kind of a side view of that, a drawing view. You can see this is actually showing a reinforced CR1 system, but you can still see a couple of things I'll point out. Number one, even before we poured that wall, the little square you see down at the bottom, that's our Hydrostop B25 water stop. So we have an expanding water stop that you would specify that you would use in that joint between the footing and the wall. Very important. Every below grade project like this has it should have some type of water stop in that joint. And then you can see where they did a detailed cant strip of joint sealant right along the bottom inside corner there before they then put the CR1 waterproofing and then the drain board. And then something I didn't show you in the other picture, but there's a drain system. So that's kind of a French drain system they've used with a perforated PVC pipe, usually surrounded by rock. And this way, the water, as it comes down the wall, it can be filtered through that, and it can be carried out to wherever they're moving the water. Remember, we talked about moving the water away from the building, so that's part of that. MAPEI does have all the components. I've referred to them here a little bit, but we've got all the accessories needed to go along with the main CR1 system. We've got multiple types of drain board. That first drain board you see, the 25, that's the one I just showed you on the oil change pit. The 35 is a heavier duty drain board. That would be used for horizontal applications, like say between two slabs of a parking garage. You know, that's a heavier one. There's a reinforcing LMR fabric. We've got the 2-part and the 1-part joint sealants that are used for detailing work. And then there's the B25 expanding water stop that you would put down between the base slab and the wall. And finally, with CR1, this is, well, not finally, but second to last here. This is a really neat application. I wanted to actually show you the detail of it first, and then I'm going to show you some projects where it was used. But this is we call this a direct thin set tile over system for CR1. So this is a system where you have a structural slab, and then instead of having to have a waterproofing system and then say drain board or something like that, and then maybe your tile or your pavers, what this basically does is eliminate the drain board. So if you don't have a need for drain board there, you just want to waterproof that slab, that upper, say it's an upper deck slab. It basically consists of putting down the Planiseal CR1. We recommend a reinforced system. So CR1, the fabric, and another layer. And then we would actually do another skim coat of CR1. And it's hard to see in this detail, but you would broadcast it would be a full broadcast of coarse sand into that top layer. And we call that broadcast refusal. So in other words, it covers the whole area. And then after it dries, we vacuum up the loose sand, and you're left with a rough surface that you can then apply your tile mortar or your mud bed, whatever it is, right on top of that. So what does that do? That means that, say you have a balcony where you have height issues to overcome, you have a door that opens up, and the system, with your tile and everything, it can only be so high. So you want to actually try to minimize the height of that system as much as possible. With this, you just end up with a very thin layer of waterproofing with this whole system, and then you have your tile. So you can get a much lower profile. And here's a better illustration of that. You can find this on the MAPEI website, but you can look there. Starting from number 1, you got the concrete. There's the 2, 3, and 4 is the reinforced CR1 system. 5 is where they broadcast the sand into there. And then look, 6, they put their tile mortar, and then their tile, 7, 8, and then sealer. So something I'm going to point out with this, it's a good illustration, but you know what else it shows? It shows that from the concrete all the way up to the finished tile, you can use MAPEI. And why is that important? Because you could get a single warranty. I mean, why wouldn't you use a single company if they can provide the whole system? And I'm not even showing on this drawing, let's say this was a renovation, a restoration where you had to repair spalls and maybe rusted rebar on the base slab. Guess what? MAPEI makes all the concrete repair mortars. We make all the rebar coating and protection, corrosion protection, everything you would need for that. So you could literally start from the bare raw slab all the way up through the waterproofing, the mortar, the tile grout, the sealer for the tile, all MAPEI products. And in fact, I'm going to show you a project where we did just that. So, well, this was a smaller project. This is a nice example where you can see this was a balcony. This was in New Orleans. On the left there, they've applied the first coat of MAPEI Planiseal CR1 and the reinforcing fabric. And then in the center there, they've applied the second coat of 60 mils. And on the right there, you see where they put a skim coat, and there's the sand. So that's basically your sandpaper look. And then right on top of that is where they're going to then apply the tile mortar for that project. This was another project. This was one where they did use MAPEI from ground up. This was kind of a large project with a system of outdoor balconies, and then it had like these transition hallways that were open to the air to go between the balconies on either side of the building. They used a 120 mil reinforced system, and then they did the sand broadcast. I don't have a picture of that, but on the right there, that's the finished tile before it's obviously cleaned and sealed and everything. But you would never know that was waterproofed under there, but it's fully waterproofed underneath that tile. This was another project with CR1 in Miami. Great project. It was called the Grand at Doral Condos right there in Miami. And they used CR1 for this entire pool deck before they put down a paver system. And then look, you can even see, I pointed out where they used the CR1 inside of those large rooftop planters. You can see the green if you look closely inside the planters. And when they're ready to do the finishing touches, they'll just fill that planter with dirt and plants and everything else, and you're good to go. So a lot of applications, and this is actually a rendering of that project when it was complete. But this is really what it ended up looking like. There's your deck, waterproofed, and there's your planters on the right with everything in it, with CR1 protecting from water escaping. Now, this was actually a project. This was a nice project over in Jacksonville, Florida, where they did want to use the drainage board. And you can see, because all the way down the center of this large balcony and plaza area, they have drains right down the center that are going to be ultimately incorporated into the tile system and everything else. But they put down the CR1 system. It was a 60 mil system with the horizontal drainage board. And then finally, last thing I'll say on CR1, Great application here. I mentioned a split slab. So if you're not familiar with the split slab, it is a deal where on the bottom side, let's say number one, you see the base concrete slab. Underneath there, you would typically have some type of occupied space. Maybe that's hotel space or offices. And then you can see the CR1 system, reinforced system, is put down. And then on number 5 there, you see the drainage board. That's the heavy duty drainage board. And then the top slab is poured right on top of the drainage board. And that is the drive slab. And you can obviously see the cars in the background. So that is how you can have a parking deck or a slab where you have vehicular traffic on top, weather, rain, vehicular traffic, spilling oil, whatever goes on up there. And it's not going to penetrate down to the occupied space. So let's shift gears a little bit here, and let's talk a little bit about self-adhered rubberized asphalt sheet waterproofing. So this is another popular system. Self-adhered system typically is comprised of 56 to 61 mils of asphalt that's adhered to a very thin film of polyethylene or plastic, and then it's got a peel-off backing. So it's pretty straightforward. What are some of the advantages of this? It is fully adhered to the substrate, like CR1. It's just important that they roll it out completely and get all the wrinkles out. It is another cold applied product. It's got a lot of flexibility and elongation. So just like the CR1, if you apply this and there's some minor cracks that form in the slab behind it, it'll flex and accommodate that and not let the cracks show through. Something architects like about this product a lot of times, it is manufactured to a controlled thickness. So it'll always be, say, 61 mils, or 63 mils. It'll always be that thickness. You're not depending on somebody, their application in the field to do that. And it's got a very high hydrostatic pressure resistance. Some of the highest of all the waterproofing can resist a lot of water pressure. So talking about MAPEI's, this is MAPEI's primary sheet applied waterproofing. It's called Planiseal Membrane SA. We've got the full system that goes with this, the membrane, the drainage board, everything you need. This actually is on the higher end of thicknesses. So it's 63 mils thick, which is toward the top end of what you see out there in the industry. Very high resistance to water, 231-foot column of water. It can be applied from 40 degrees all the way up to 100 degrees. So a lot of application range. And you can see, I won't read them all, but very similar to CR1, lots of substrates it can be applied to, lots of applications, tunnels, all types of applications that this can be used on. This was a project, this was an elevator pit where one of our peel and stick membranes was used. And you can see there in the top left, they're applying the primer. There's a primer that goes with it. And then bottom left, they're rolling it out. They're peeling the membrane, the backing as they roll it out. Top right, you can hardly see that, but he actually has a roller where he's getting out all the wrinkles. And then, of course, the center there is the finished product. You can see where they went out onto the slab, the footing when they did the waterproofing there. And then this is kind of a breakdown showing you how all that works. What we just looked at basically, where you have the concrete, the primer, and then you have the actual membrane, Planiseal membrane, the Mapedrain, and then down at the bottom, I am showing a product that we have called Mapedrain TD. It's basically like a 12-inch wide, super thick drainage board that you can run along the bottom. Alternately, contractors will often do like the picture I showed you much earlier, where they'll have a French drain system with a perforated pipe and rocks down at the bottom to move that water along. And then finally, this type of system can also be used on a balcony. Great for balconies. I see it used a lot on balconies. And you can see here, I'm not going to read all these out, but once again, you can see from the concrete slab all the way to the finished tile, MAPEI products, all the way across. MAPEI this, MAPEI that. So we've got everything you need for this type of application. So I would encourage you to think about that. There's not a lot of manufacturers that can do everything from concrete repair up through ceiling tile with the waterproofing in the middle. So it's something to think about when you're specifying or doing a project. So, before we were having technical difficulties, when I had animation to this slide, I had this little choo-choo train coming in, but you don't really get the effect of it now. But what I was going to say was, let's pull the train up to the next stop here, Cementitious Waterproofing, and talk about this. So, Cementitious Waterproofing, really great product. It's got a lot of applications. Cementitious waterproofing is easy to mix and apply. It's usually like a bag and water, or a bag and a gallon of admixture and water. And it is a very strong, it's cementitious, right? So it's a durable waterproofing. One thing about this, I didn't really mention about those other products, but this can be left exposed if needed. The other ones, they really want you to cover it up before, say, a few weeks pass. This can be left exposed. And one thing you find, certain cementitious waterproofing products, they are good for negative side waterproofing. And I'm going to show you a project with that. And that's because that's good for when you have water coming in, but you can't get to the backside to repair it, like an elevator pit. And they're also usually compatible with other waterproofing products. So I think I have a picture here. MAPEI's Planiseal 88, great product. It comes in gray and white. It's everything I just said. It resists positive and negative water intrusion. And it's usually applied with 2 coats is what you usually put on there. It is a breathable product. So it is a waterproofing, but it also allows moisture vapor to escape, which can be important in certain applications. And that picture I show you up at the top right there, that's actually where it is used as a transition between the below grade and the above grade system. So, in this example, the CR1 is used below grade. It terminates at a certain point, and then we have the Planiseal 88 cementitious behind it, up out in the open, and then up behind, say, the above grade stucco, air barrier, whatever you're using, because they're compatible with it. This was a project I wanted to show you. This was up at Mississippi State University, where they actually had a lot of buildings on campus that were leaking, basements that were leaking below grade. And we solved that problem with 2 products, MAPEI's Planiseal Plug Water Stop. We used that all along the bottom corner as like kind of a chamfer to stop water intrusion there. And then we coated that bottom area with Planiseal 88. You know what? It worked. So no more water problems. So if you have that type of situation, give us a call. Here's the other MAPEI cementitious waterproofing product I want to talk about. Mapelastic is, I don't know what to say about it. It is just a fantastic product. MAPEI has had this product for more than 30 years. In fact, you see up top, worldwide, more than 3.2 billion square feet of surfaces have been waterproofed. It's probably more than that. That's kind of old data, but needless to say, it's been used a lot around the world for waterproofing. And something about it, I'm going to show you this. It is a cementitious product. This is not an acrylic paint or anything. It's cementitious, but it's flexible. And I don't know if you can see. I can't see myself here on the camera, but this is a sample of Mapelastic. It is as flexible as if I was holding a sample of cured paint. And it remains that way throughout its life. So that means it's resistant to cracking and things like this. It's also very resistant to sulfates, chlorides, carbon dioxide, all these types of things. And something it's really good at, if you see there on the right, a thin layer about this thin, this is about 80 mils of Mapelastic, it actually gives the equivalent protection of a little bit under 1.25 inches of real concrete against, say, chloride penetration. So what am I saying? If you had 1.25 inches of concrete you poured on a wall, the amount of protection that would give to the rebar inside the wall is about equivalent to what this 80 mil layer of Mapelastic applied to the same wall would give. And I'll show you where that's relevant. So first of all, this was a project, this was a dam in Mississippi where terrible shape, it was just completely deteriorated. Two pictures on the left. They used MAPEI concrete repair mortars. They used our corrosion protection to repair all the structure of the dam. And then the two pictures on the right, they coated the entire dam in Mapelastic. So this is like the backflow over this is like the overflow dam from a lake, Lake Hazel. And that Mapelastic is now going to protect it, the concrete, from corrosion from that constant wet, dry, wet, dry, wet, dry cycle. And this is about 5 or 6 years ago. I passed there about a month ago, and hey, it's still holding up great. It's a little dirtier than it used to be, but it's holding up. And then here is an application that you might find really useful for Mapelastic. This was a parking garage where when they built the parking garage, they put the rebar too close to the surface. Bottom line, the formwork got off and the rebar was probably, I don't know, a quarter inch from the surface. Well, what happened was, because it was so close, moisture was able to penetrate. The rebar rusted, it spalled the concrete, and you know what? That probably happened decades before it should have happened if the rebar was deeper into the concrete. So great opportunity though for Mapelastic. So the contractor came in, he cleaned that rebar, he did a little bit of patching, and then you see on the right, he skim coated the whole thing with 80 mils of Mapelastic, and now he can feel confident that even though that rebar is still a quarter inch from the surface, it's probably now got about 1.5 inches equivalent protection, and it'll last, hopefully it'll last decades and decades more. So let's land it here with one more product line with MAPEI, and then we'll go ahead and wrap it up. Polyurethane injection grouts and resins. So there's really two types of injection grouts, polyurethane grouts. These are used typically to fix cracks, to fix water intrusion, even to fix areas behind a wall that have fallen away. The soil has fallen away, and you have these large voids, leaks in manholes, leaks in tunnels, things like this. And there's two types. The first type is a hydrophobic grout, and that would be like MAPEI's Resfoam HB 45. And if you just think about the word hydrophobic, hydro meaning water, phobic, think of phobia, fear. So you could translate it as water-fearing materials. So these are products that typically, when water hits them, they cure to a rigid closed cell foam. Water hits them, it doesn't penetrate, it resists them. And these products actually don't even need a lot of water to react. They use an accelerator. They pump it into these cracks. They pump it into loose soils. It fills the cracks, and then it actually expands to up to 750% of its original volume to keep the water out. Now that, as opposed to a hydrophilic grout, think about hydro, water, right? Philic, what do you think of philic? You think of, philic actually means love. So think of Philadelphia, city of brotherly love. So water loving materials. It says that because, number one, these products really react in the presence of water. They use water to react. You don't add an activator typically. They react in the presence of water, and they also will seek out small areas, cracks, fissures, and are great for repairing manholes and municipal water treatment areas, dams. Something else to keep in mind, both of these products are NSF water certified. So they can be used with potable water applications, water treatment plants, things like that where they need to be NSF certified. And this kind of shows you some applications where you can see 3 of the pictures. They're injecting that foam in like a wall. They're repairing the wall there. The top left picture kind of gives you a visual of them filling earth behind this manhole. So that was soil that had fallen away, and they're basically pumping it through that structure into the surrounding earth, And what does that do? That ends up kind of encapsulating that structure with a waterproof gel foam layer. This kind of shows you how they would use it for crack injection, fixing a crack. Typically, they're drilling a hole at about a 45-degree angle, and then they'll put in what's called packers, and those are basically just a little receiving tube that they put in the hole so that they can plug in their injection nozzle and pump the material into the nozzle. And then this is the situation I just showed you with pumping behind a wall. Same thing, but you can see they're pumping the material behind the wall and it's filling behind that wall. So as we wrap up, we just have about 2 more slides here. Let's talk about some important considerations for a successful waterproofing project. And I think we're right on time here. We got a late start, so I think we've got about 8 minutes to go. So it's always important to insist on a pre-construction conference specifically for waterproofing. I've found this so many times. Really, whether you're the general contractor, the subcontractor, the architect, whatever it is, there should be some waterproofing should be included in a pre-construction conference in some type to talk about what are we going to do, what are we going to use, what's going to be the phasing of it, how is it going to work around other trades. Very important, because you don't want to figure out that stuff later on while the job's going on and now you've got a difficult situation. Insist on smooth monolithic substrates wherever possible. Anytime they can grind down sharp edges, they can fill in holes before putting the waterproofing, they really need to do it. I would even say if you have a masonry wall below grade that's got the mortar joints in it, I would insist that they bring those joints up flush. Bring them up flush with the wall, because you don't want to create avenues behind the waterproofing for water to travel. Make sure everyone is clear on how the waterproofing details and transitions will be done. This can tie into the pre-construction conference. Hey, a lot of times it's pretty straightforward, the big area you're waterproofing. We're just rolling it out, we're just putting it down. But what happens when we transition to, where it bends up the wall, or where it goes around a pipe, or where it goes, there's a trench drain in the slab, whatever it is. What do we do about those details? Let's have that established ahead of time so that everybody's on the same page. This is very important. It can be overlooked, but for elevated waterproofing applications, say an upper deck, always check before the project begins to see if the underside of that concrete slab is supported by an unvented metal pan deck. If so, an impermeable waterproofing membrane usually can't be used on the top of the slab because moisture can become trapped. And if moisture becomes trapped, it can delaminate that waterproofing. So what am I talking about? Okay, they poured this concrete slab. They first put up this metal pan deck. In fact, let me show you here. Look up top there. They put up this metal pan deck. It's a structural deck. They poured the concrete on top of it. And then you come back on top of that concrete and you put 100% waterproofing product. Nothing's getting out and nothing's coming in. Well, what happens if somehow there's a fault or there's a leak or something and water gets into that slab somewhere? Where's it going to go? It can't drain out the bottom because this metal isn't going to let that happen. Water's going to rise. So now it's going to push up. Now you've got this positive water pressure pushing up against the underside of your waterproofing membrane. Not a good situation, and most manufacturers won't even warranty a system with that being the case. So, what you want to have there is a vented deck, and you can see 2 examples at the bottom. Hey, I wish that more often that would be specified, but a lot of times I think the structural construction of a building, when they're designing the structure and the concrete slabs, they're not necessarily looking at what are we going to put as waterproofing later on. So I really think that's something that probably the industry needs to coordinate better, but it's important. And then finally, it's important to follow all manufacturer guidelines. This goes without saying. Do what the data sheet says. And hey, if you have any questions, call me, call your local MAPEI rep, call technical services. We're there to help. I'm telling you, we've got a great team, and that's what we're here for, whether you're an architect or a contractor or a distributor, whatever it is. So, well, that pretty much wraps it up for me for this session. So, sorry about the kind of raw slide presentation here with the technical difficulties, but hopefully you got something out of that. And hey, any questions you have, let's talk about it.
All right, excellent presentation. We do have a few questions from the audience. So our first one, how do you recommend adhering the MAPEI drainage board to the Planiseal CR1 waterproofing?
Yeah, that's a good question. There's a couple of ways you can do it, but once the CR1 waterproofing is cured, the drainage board really only needs to stand up until the backfill dirt is applied. So it's only a temporary adhesion. So I always recommend either using just a regular polyurethane joint sealant, or you can actually use more of the Planiseal CR1 waterproofing. Just dab some of that up, brush it on, stick the drainage board to it, and then backfill. But that's a good question. Thank you.
Great. We have another one here. Do you recommend a two-component like Mapeflex P2NS for sealing larger cracks?
Yeah, I recommend a P2NS definitely for larger cracks. Yes. So anytime you get a wider joint, a larger crack, usually when you start getting up over a ½ inch or so, it's always better to use a two-component chemical cure polyurethane, because that's what it is. A two-component cures chemically, whereas a single component cures, it's a moisture cure. And underneath any of these waterproofing systems, if you use a chemical cure, it's going to cure out faster, and you can put the waterproofing on top of it and not worry about moisture not being able to get to that sealant like a single component to finish curing it. So yes, I'd say especially when you get up to like 3/4, 1 inch and wider joints, I'd use a 2-part.
All right. What can be done to waterproof an elevated slab if there is an unvented metal pan deck underneath?
Yeah, so good question. We were just talking about that. So what can you do? My recommendation would be to use a cementitious. If there's no other option to get around it, use a cementitious waterproofing that clearly says on the data sheet that it's got vapor permeance. So I would consider something like, we have a system called the Planiseal 288, which is a variance of the Planiseal 88, which is a waterproofing system. So you could put that down and then go up from there with whatever other tile or whatever you're going to do up there. But that would allow the slab to at least breathe somewhat and let some moisture escape.
Great. Another question. What system do you recommend for steam showers?
For steam showers, so when we get into steam showers, we're kind of overlapping a little bit into our tile and stone division of MAPEI, where they have a lot of great products. From what we've talked about, just as an example, Planiseal CR1 would work for that. In fact, if you read the data sheet, it'll tell you it can be used for indoor applications as well. I would say, though, if you were going to do that, to look at something on the tile and stone side, like MAPEI's Aqua Defense product, or one of those type systems, or even our MAPEI's waterproofing board system, which is really great. It's all in one. It's a board and waterproofing. So there's a lot of great products. But yeah, reach out to customer technical service, and we can definitely guide you on your specific project with that and the rest of the components of the system.
Great. And it
Good
looks like
question.
we have one more question.
Yep.
Does MAPEI also produce a bentonite waterproofing system?
Yes. Yeah. Oh, thanks. That's a good question. Yeah. So we were limited on our time here. Couldn't talk about everything, but I did say in the beginning that we have more than what I'm going to be able to present here today. And we do have a really great bentonite system. So if you have a project where you're looking to do bentonite, please give us a call. Our bentonite is actually a really, it's kind of unique in the sense that it's really got more bentonite granules per square foot, some of the highest on the market, I'll say. And the other thing is that MAPEI's bentonite is sourced from a different place than pretty much everybody else's bentonite. And what that means is it tends to swell. The bentonite granules actually swell 12% more so than typical bentonite. So you got more material swelling more, within that sheet. So that means better waterproofing protection, and all at a comparable price, to everybody else. So yeah, please let us know if you have that type of system, and we'll be glad to help you.
All right, that seems to be all of our questions. As a reminder to our audience, if you have any questions in the coming days, feel free to reach out to MAPEI Digital at mapei.com, and we'll get those questions over to John, get some answers over to you. Thank you so much for joining us today, and thank you, John, for presenting.
Yes, thank you all so much for taking time out your day. It was a pleasure. Appreciate it.